Okay, so welcome everyone to this new stream of EagleFly, the experimental debugger. Today we will continue um, implementing the usage code for the extraction, symbol extraction, and I believe that was the last thing we did. So yeah, we can go and continue on there. Please, if you have any questions about the project or the thing that we will do today, please ask them after the stream has ended, and we will take a look on them. Okay. With that said, I would like to start by saying that we open for coder. Where's for coder? Okay, so let's see. Where we left off. Where is it? It's in third. No, EagleFly tracer. And I think we left it here where we said it was like the minimum thing that we basically had idea of what to do. I mean, it was like, oh yeah, it's here. Okay, so it's get line number. We basically say like, hey, we know that we want to display several data. We want whenever a breakpoint happens, whenever a breakpoint it's set in the process, targets process, we want to execute several instructions, several commands to the the commands doesn't have to be executed by the tracer itself. It can be done by the what we call the debugger manager, which I believe in the future is the one that's going to do all this stuff. But it's really, right now we don't have any kind of manager being as that said, but we are doing it all here, basically inline. And it doesn't matter. We will get the point where we see that the code wants that, and I think that's better. So for now, we just have some kind of a. We say here that we want to extract some font, do some font, extract some symbol contents from somewhere. We don't know where. I just tell, and yeah, but this the usage code and the tracer doesn't want to care about that. It's just, hey, give me all the symbols, and there's a function call that's gonna load the symbols for us. In this case, it's gonna be this is platform dependence. So yeah, and basically, pretty much right now we have dealing pretty much with a lot of stuff platform dependency here. So we have to have a way, and this is hard because we know certain parts that they're not platform dependent, as a render UI, probably the manager also is not going to be platform dependent, but all this stuff like extraction symbols, all this stuff should go here, So I think this is good, how it's done for now. Now, the thing that it does is, okay, we have to load symbols from source, load me all the symbols, and from the source, okay, from source code, we are right now just dealing with the source code itself because yeah, I mean, it's gonna be, that's the first thing we are gonna load. And yeah, we got something there. We would try and kind of do something with it. I don't know what, but it's we're gonna get some table that later we can use every time that we have a special command or special event that the debugger tracer itself has done, has executed. Which in this case is like, hey, we know that I mean, we have like these kind of specific things, like we stop on this RIP, yeah, and well, actually, now that I think about it, we move past that. Okay, we return past that. We write the process memory. Probably, well, since probably we wanna do this right here because yeah, I mean, it doesn't matter because it's independent from the process itself, but it's just for sake of sanity. Where, I mean, this is like the basic stuff that the target or the tracer has to do to replace the instruction that we already overridden with a in-tree instruction, and now we want to replace it with the original instruction. That's basically the thing that we're doing right here. So I think it's good to have it right there, and that's gonna define like, hey, we no longer need that instruction, but it's reset it to the one that we originally had there. And yeah, so now we can do everything as pleased. For example, we can say okay, give me the instruction pointer there, and with the instruction pointer has some kind, we want to have some kind of way of, from the instruction pointer, get the symbols for that or the set of symbols that map to, since we know that there's a range of instructions that map to a specific expression in source code. We have, I believe, some kind of it's something really rudimental here. It was where is it? Oh, here, the address line map. That basically, with the address line map, we have some kind of memory index ranging, which is okay. This is the line that maps to a range of addresses, and that's it. And that's a bunch of architectures, and we get symbol tables, sim tables. Okay, now I think let me see. And we define, yeah, we have a symbol table. I know we want this to be this, or I mean, it's gonna be in memory somewhere, but I mean, the symbol table is not gonna be something that we store properly, I mean, it's something that's gonna be transient. So this, I think we need, I mean, we can probably use the dispatcher one. I don't think the dispatcher has some kind of memory here. I don't remember. Map. some contents. We have thread ID map. Okay, thread ID map. It's not the thing that we care. Although, what was thread ID map doing? I think it was something busted that we had there that we didn't. Well, yeah, we didn't pretty much do anything with that. So we can. Well, I'm gonna leave it right now because it doesn't matter. So we want to have a nice way to gather that data, and probably the way to do that is to have some kind of table that we can look at and say, oh, this line maps to this range or this range. We have to look. We have to have some way to do that. So we can have something like this. I don't know how many symbols they will be. Probably this is not the most performant thing, but we can start by that and take a look. I would like to see now basically, now that we've done I mean, I wanna start by this, saying like, hey, let me get let's start by getting the line number, that's one symbol, and getting the symbols for that line number, that's another set of symbols, and then getting the address pointer, that's basically another symbol. And yeah, so let's see, how can we do that? I mean, we already had the functions being set there, so we only have to implement them around. So I think they're here. Let me see. I think here's where we can have a nice hash table, because since we know how we have a key for a specific key for the address on the instruction that we are looking at. Now let me think if get a dispatcher. Well, I'm gonna start by the simplest and probably, yeah. I wanna foresee this. So let me see. First, let's see how we manage it to do it, and then we can get it, I guess. So probably I can have something like this. Where is it? We get a line number there that maps to a range of addresses, and this is gonna be a this is address line map. There we go. And this is gonna get me on to the free context or IP, and you probably want this instead and this instead. You probably want something like this. This is I remember how we call it, dispatcher state. This in contents. Something like that. And so now I want to, for now it's gonna be super simple. I mean, because this is gonna be I think I would like to have some kind of super, since we know that address spaces are not well, it's because symbols are like this kind of operand pairing, you know. You have several operands. For example, one target should one thing could be for example, we have here some mnemonics, and we have a register and we have a pointer to memory. So it's always going to be some kind of pair in there. It can be a trio, it can be a pair, it can be something. So we want some way of well, I was thinking on not going that way, but well, I don't know. If we see that way, we will change it, but it doesn't matter. This is gonna be 132 sync contents first address line, first address line, probably we can do this like this, address you can say something like number is in between, number is in between result equals to line at number, how is called, line num. And you know, I mean, this is the simplest thing we can do right now, you know, just for starters. So yeah, I think I like that. Now it's a single entry. we can have something like this, and this can have its own, I believe, line number. So I don't know why did we define symbol itself? Oh, here it is. Oh, so this is the whole thing. Well, I think we can collapse this, I think. I don't know why did we separate it. Address line, address being more, yeah, we have that. We had it as a pointer. Doesn't matter. I don't know, it's okay, yeah. I know what's the FPO, but it's something that we can gather. We have target types, target type. And this can be this is gonna be, let me see, we have a symbol type, function, global function. I don't know, we also want some kind of they have some kind of way to have, we know some, I mean, they're public and private, we don't care about that, which is, I mean, I don't know why they do this kind of public and private stuff. I think it's stupid, because I mean, if it's a, I mean, the only difference is that they have the names manual. Well, I don't care if they have the names manual. I can get that from a simple map file, I guess. It doesn't matter. I mean, it doesn't give me any kind of relevant information. I mean, the only relevant information here is the private symbols. So I mean, probably what I like to have now that I think about it, it's something that got to my mind. Probably we can do this as this. Look, where is it? I'm gonna move this right here, and I'm gonna do the next thing. We have a begin and end, and we'll have here instead of this. Oh yeah, we can keep this. I like this, and then here we have inventory and symbol entry block. You know what I mean? This is the thing that I was thinking. And then we can do this, and then we can go straight down, and we can have it basically as an array. I mean, we don't have to have a linked list. I just want an array that we can gather. I mean, it's like if we were reading basically the binary. It's like if we having, like this amorphous binary source mapper. Binary source mapper. That was the thing that I was like trying to imagine. This binary source mapper that basically tells us really, really fast where should we go and look. Because we know the address, beginning and addresses for a single expression, so we only have to go to that address and gather the symbols for that block, and I think that's even more better. yeah. Instead of having the hash table that probably is not gonna it was gonna be slower. So yeah. So the symbol entry block, I like that. It's gonna be there. We're gonna have a bunch of entry blocks. We don't care. And the symbol entry block. Well, now I think about it, it should be right here, and the symbol entry block is gonna be there, and it's gonna have probably like this. It's gonna have the address itself. It's gonna have, I don't know what's this, but we can, if we don't need it, well, we can just take it out, I guess. It's gonna have a symbol type. It has whatever the validates itself, so we can print it out. Right now we don't know what we're gonna do with the we'll probably this inventory to target types. This is I define it more for be like the fundamental type and the sim type name, like some kind of type definition that the user did with the type itself. I don't know if we would like instead to have some kind of I think we can, oh, it's not, I think we're gonna put it right here, and then I don't know, let me think about this. We have a type, and pretty much many of the stuff that we're gonna look at in source is gonna have its own type, but let me see if we can let me see. We can get rid of this. We can get rid of this is the fundamental types. This is like the mapper for a scene type name. Probably one like this. Probably yeah, I like the pointer. And yeah, I mean the thing that I was like thinking is like, for example, functions. I mean, even though they have a type, a return type, they have also parameter types and stuff like that that we also want to look at and say like but of course the parameters are going to be other symbols and stuff, you know. So I don't know, I think we can do better, but for now I think it's gonna do it. We're later gonna kind of get some way to get it, and if this is gonna be yeah, some way to easily gather the target type if we need it, you know, some kind of that way. So yeah, I think I like that. So now we will change everything because we will do something more simpler, and the point here is to okay, where am I here? Spray symbols, a line number, get line number from address. Okay, so now we can go and define this more like in a single call, I guess. We can do this like so we have address line map, so I want to have like an arena here, you know. So it's gonna be like some kind of a, I mean, it's not even that okay, yeah, like, I mean, I want an arena or like a temp memory stuff to gather this stuff, you know. I am kind of envisioning some I mean, we can have this pointer, but I mean the pointer is gonna point to the next thing, so we can do it. Let me put some Melton so I can explain it better. Let me where do I see okay, so let me move a little bit here. We can go right here, I guess, and we can say that we want this is gonna be called binary source mapper. Yeah, this is the thing. So I kind of envision some kind of super flat array that Benny has. It's like if you as if you look at us in memory, you know. So that here goes the address space for each instruction, and at some kind of address, and this goes right down. And you know, we know that each set of instructions in binary in assembly uh, maps to what it's called an expression in source code. You know, and if you think about it, then we have a neat and easy way to just gather everything as an array, you know, because we have the address that we're going to stop. It's like, hey, you are here, no, you are here, no, you're here. So it can be, we can have like some fancy way of looking at the table, I guess, and just go directly to there, you know. It's like, hey, you have an address, go to there and go to the block. So I want to say something like, and this of course they're gonna have a bunch of symbols, you know, symbols. It's gonna have types, symbols, everything. Now let me yeah, okay, so we can get this into something more like this. Where is it? I can go, I want to say more like this, you know, like so probably this can be get symbol entry block. We're gonna go right there, and we can say we have an address space. We can go, and since these addresses are gonna be like some kind of like a memory itself, yeah, we can do some kind of let me think. I want like a neat way of indexing, mapping, like a mapper of address to indexes, so we can have I mean, probably this is gonna be crazy, but I think I like this, something like get index from address. You know, and then we can have here some index where we know we're gonna enter into it, you know, so we can go mm, I mean, since we just have like, well, we have the beginning and address. This is I am like imagine like the address space, you know, like if literally they were occupying this address space, but they don't. They occupy pretty much less space because it's just like a reconstruction of the space. You know, we don't have the space. We have the reconstruction. I was like, well, I want to have an array here, but let me see what's the. We're not gonna have this anymore. We're gonna have the first address line, and we probably I don't know if this is totally crazy, but 4096. Yeah, I mean this has the little peculiarity that it's gonna have. I mean the limits, which probably we don't want, but also. I mean the index is kind of useful because we can go and I think I would like to do something more like this, and this is gonna be more like this, middle address. And probably, I mean, it's gonna be kind of crazy, but it's gonna be like a binary search, you know, which I think I like more. Because I was thinking like how to put indexes there. I mean, it's gonna, because we have to look at each begin end, you know. We don't know how many ranges are between some kind of address. We just know, I mean, we know because of the index now, and that's good because now we know how many times we have to iterate once we got from one place to the other, you know. And I think that's neat. But yeah, because this doesn't tell me pretty much a lot of things, but the index, it does. And probably another value that tells us well, think I like, I mean, this is good with the index is good. And probably we can do it right here. We're gonna go to the scene contents, and this is the middle block, or middle address line map. And we can say like and the reason that I don't have, I mean, have I don't I don't have line number like the index is because I mean, it's not like such direct thing that we can do if we do it that way, because remember that expressions can be inlined, so even though they are in the same line, uh, they map to different ranges, you know. That's why they cannot be repeated. That's why I have the index. So yeah, then probably I can, this can be like the ID, I guess, some identifier. And yeah, I'm thinking like, I mean, I like the structure. I'm trying to deal with the simplest thing. I mean, well, let's do the stupidest thing possible, I guess. So let's go to we have the ID. We can say well, yeah, I think line map ID. And so I don't know if I mean, we could like map the whole thing, you know, so that even though we have symbols, that doesn't get you to, I mean, something like this, I guess. We have like a big bunch of symbols that map to the same line. I think it's okay. I mean, we'll have the whole thing of symbols, and because that's the only thing he cares about, a big data of symbols here, you know. So it's like let's see if we can go with this way, you know. And we have the address, and then we have we can do something like this, where we, instead of doing this thing, you can just say index, and we can do something like, so let me see how can we do this binary search. It's not like, what about this? Because I was thinking on this, like probably we can say, uh, uh, so in that way we don't have to do the binary search. It was kind of crazy, and we don't need this. Where is it? We can have it if we want, but I don't think we need it. We just have to have this. I want the first. Now, since we don't know the specific place where we have to go, I mean, it would be the same, I guess. It was a nice try. Because if you think about it, we have to basically fetch each one. We cannot offset it by some kind of quantity. I mean, the only way that could be possibly is if we really, map it directly in address space. Uh, like in the thing that we have the address here. We have a mapper that directly maps directly to it, which it's kind of ridiculous because it's it's not. It will be all propagated and totally um, yeah. It will be all propagated and all sparse without need. So I don't think that's what we want. we want more like something simple, I guess. So I mean, I like the we like this one. I think it's good, I guess. For starters, we're not gonna think it too much. Later, we're gonna see if we can find something better. So for now, I guess I'm just gonna iterate for each one like the way we were doing before, and say we have the next, the symbol entry block, line map next, and we have here line map, and then we can do this, then this kind of resolve, how is called this symbol entry block. And we can implement this basically. And this can be And for this one, I don't have a particular thing to do, so we can probably do this. This is gonna be display, how's it called? Symbol entry, symbols, and well, probably we want the line number again. So probably this is more like this. Get map, probably something like that. Right here would be probably we can carry it like this, I guess. Yeah, like that. Probably like that. Probably like this. moving on. This is gonna get me this. And this is gonna be pretty much the same as this. This is gonna be how it's called, symbol entry, first entry, well, entry, entry equal line map, first entry, there's no first entry, how do we call it, a symbol entry black, line map, entry equal entry, next, for have that, have buffer, basically we're gonna write every time, and we probably want to, or we can use the same buffer, I guess. We can do this, and I don't know the order of it, but for now we're gonna assume it, just print it out. And probably we want to do something like this. Well, it's not necessary at all to have it, you know, it can be. For now, I'm just gonna print it because since we don't know how the symbols are, how or whatever, but I just want to print them, you know. So we can do something like this and. can probably do it a little bit simpler, I guess. Can do that. We got the symbol. You can say symbol. And then we can say entry. What's next? Entry target type. Buffer. Okay, what's it? Oh, the target type. So the target type is basically same type name. Target type, same type name. And the target type probably it's so something like that. And we can have something here fancy like where we well, it doesn't matter, I guess. It's okay. Since there are not a lot, I think we can, I mean, if we have more, we can take a look at that. I was just like putting some strings, hard code strings, so that we can see the name of the type, but it's alright. So for now, let me see, we can do that. Let me go here and solve the errors, missing type specifier. I'm sorry, this goes right here. And this target type target type well, it says a memory index again. I guess you can put this all eyes. And D, where is it? Oh. Okay. And what about them? And what about, I was like trying to find the best way to think about this. Okay, sim table is not a member of sim contents, and we probably don't want to do this anymore, and probably this is more, I mean, we don't have any kind of uses right now for this, so probably want to take a look at that later. Alright, so probably I'm just gonna say if I choose in contents, just select first type and first line map. This is this state, and how do we call this? There we go. Alright, and of course, I mean, it's not gonna do anything right now because we haven't done anything with that, you know, but at least we have like now some kind of more like we are like seeing what we are looking for, you know, and that's neat. I'm starting to see the structure of the things that we want, the data, how the data structures I want it to be, and so that's gonna be pretty, I mean, it's gonna be pretty much faster for us to go and grab that data wherever it is, just go for it and put it in this format that we specify here, well, not here, which is some kind of, it's a kind of mapper thing, which of course we would like to have some kind of structure in there so we can grab it. And so yeah, I think we can now start doing that. Let me see if we can, how much time we got left. uh I mean, I know that looking at the symbols and stuff like that, it's gonna take a little bit longer, but we can start by just looking on where can we find all those symbols. Okay, let me see. I don't care about all this. What is all this? Jesus, man. Windows is really good to make the whole thing super hard to find. I just want the symbols, man. What's all this craziness? I don't want the Microsoft symbol server. That's Jesus. So probably what I can do, I mean, before going a little bit deeper, that we can probably keep the looking for the symbol stuff to for the next stream. What I would like to do before that is to do something like this. So that we have the memory. I mean, all this data is gonna be. I don't know if this is gonna be on the load symbols from source, probably. Or I guess. Let me think. I think. Let me see what else is gonna be transient. The transient stuff is gonna be the symbols. Also, I mean, the symbols for the source, the symbols for the binaries. Yeah, because every time we compile, every time we compile back, we want to refresh all those symbols, you know. And that's a pretty we want to have, that's a pretty neat thing that we could allow to have. And it's I mean, it can follow the same kind of reasoning as for the for loop like editing, you know. I mean, I mean, something that we can do is to loop like code edit the process, you know, the debug process. We just like, hey, we're processing this stuff, now close it, and now we can do it, you know. I think that can do it, so probably it's not gonna be here. So yeah, probably that tells me that all this stuff has to go away from here. So for example, instead of having all this stuff right here, I want to do this. Oh my god, don't rush. I want to go to Windows to EagleFly. Let me go to tracer. We have this call to the tracer, and what I want to do is to have, I mean, this is like a symbiosis to debug. The tracer. I want to have something like this, and I want to do something like this. Probably have something like this. I don't know if it's not just for the symbols. I don't know if it's gonna be just for the symbols or for something else. I cannot see other thing. Symbols. I mean, since it's a bunch of data, we have to clearly handle it somehow. We have the symbols, we have input commands, we have basically but sorry, I was thinking like probably we should start by decoupling this, so we have how can I say, I mean, we don't want the symbols to be on the tracer, and that's super important. I mean, we don't care about the symbols at all in the tracer. I mean, and we were doing it all this in the tracer, but probably let's just start by moving this out, just because so I can say something like this. Deep state. And here we're passing debug memory. Yeah, I mean the tracer is just gonna be in charge of stopping execution and defining some kind of data that's gonna be passed to the what would we call this manager. So it probably, I mean, I like this stop here, and this should be on the manager, but right now we don't know where the manager should be, so probably I can do something like this. Mm. You know what? I'm gonna stop here. I mean, I want to do this, but first I want to see the symbols being reprojected. I mean, probably the loading of the symbols can be done there. Okay, I'm gonna go back in here like this, and I probably wanna, I mean, I'm gonna keep this just for now right here, and I just wanna say that this is gonna be something like this. Okay. I think I have an idea, because I was like trying to I mean, what can I do just to represent it, and we can do something like this. Where is it? This is a place where we I don't know if I wanna have it like this. it's not super clear, but probably, I mean, it's just like an idea. I'm gonna put it through here. I think I like this. I mean, it's not, I don't think it's the place where I want it, but for now I think it's gonna do it. And I think we don't have that right now being expressed there. Because the dispatcher is being represented just in the tracer itself, you know. I mean, which is fine. So probably, I mean, we're gonna think on that a little bit more later. So when I write this like this, and probably I'm gonna take read this. And we probably, I want the memory, and I want the table itself probably. So probably I wanna this same contents. And I mean, well, probably we can read things. And for now I'm just gonna pass it right there. And yeah, so I want to go to the platform layer, and I want to define the call. I want to define Win32 state where we sit. Win32 state, Win32. Oh my god, where is it? It should be here. I don't know why do we have this. Where is Win32 state? Should be free. Here you go. So Win32 state. So okay, so it's right here. You can have another pointer here. It's gonna be debug update tracer. Probably wanna call this debug update and render. Well, debug update debug update tracer. Alright, so then I can do something like that, and this is tracer, and the platform I can say I can define another one as debug update and render. Debug update tracer, and this is gonna be the definition for a type, which is here. And compile to see the problem and go to place. Okay, I was not no, I want to go here, institute debug update tracer, debug update tracer, and it's gonna have basically this. And probably well, it's alright for now. I was thinking I probably wouldn't want to pass the whole memory and just let the tracer play with the memory that we allocate for him, which I think we had some memory for it. There was this let me see, the tracer storage, yeah, which is in the place where we define that. Yeah, we have some tracer storage in there. I think we can keep it there. I think we can keep it there. I think so. I mean, I don't see no reason why not. But yeah, we're gonna pass the memory, and we can sync contents. It's gonna be 132 sync contents, which I don't think is gonna stay, but for now we're gonna keep it there. 132 sync contents when, and this is debug input, some input, and this is the target food bath, probably, yeah, target exe food bath. Sync contents, 32 sync contents, yeah, I guess probably this is, since this is platform dependent, probably this is gonna be 32 debug update tracer, and yeah, I can do this. Like this. Okay. Here we go. and 32 sync contents is that here, so we should pass that. Where is it? Tracer. Here we go. So yeah, that was the reason why I didn't want this. So probably we can take rid of this like this, and we can pass just I don't know if we can. Since it's not in the file, I need to pass it, I guess. And so but I'm gonna do another step, but for now I don't want to pass it because I know I'm not gonna have it right there, so I can just do it like this. I just want to see the representation of the callback here so we can define it, and I can keep it in the place where we have it. And the reason is because in the next stream we will make a modification, and probably we can do it right now. I just want to see the architecture, and this is Win32 difficulty tracer, Win32 difficulty tracer, and this is okay. So this is the thing that we had, but for now I just want to keep it this way. And 32 difficulty tracer, and 32 sync contents, okay. I'm gonna tracer, and I'm gonna keep it in the same place so we have a chance to change it later. And we can take this out from the equation. This state, where is this state? Oh, the book date tracer, and this is 132 the book date tracer. And we are passing is it what? Oh, we have two, you see, yeah. So it was this, and it was this. So we have this, and target full path. Target full path also being defined here, I guess. Yeah. Okay. Yeah, so that's the way. Okay. So basically that defines this, and we can play around on the next stream on how we want to lead with the memory and the symbols themselves, and I think that's gonna be fun. But for now, I think that will be all, and yeah, we'll continue on the next stream. If you have any questions, please ask them on Twitch or Twitter or YouTube, and I'll be there to answer them. For today, I think that will be all, and I will see you all on the next stream.